In this video, we are going to talk about limits of logarithmic functions. But before we talk about the limits of logarithmic functions, as usual, we have to talk about recalling what are logarithmic functions. So logarithmic functions is actually the inverse function of exponential functions, which is in the form of log of x to the base b, where b should always be positive and b should not be equal to 1, and x should also be positive. If you could recall, the x is what we call the argument of the logarithmic function, and the argument should always be positive. Now try to recall that whenever we have a negative argument for a logarithmic function, it becomes undefined. So we would really make sure to avoid that kind of instance. So therefore, don't forget that. Now let's try to go ahead and recall the graphs of logarithmic functions. Now there are 4 different looks to that function. So these logarithmic functions have a base of 10, and this generalization that I'm gonna talk about are generalizations when b is greater than 1, right? So we have here log of x to the base 10. So we have a graph that goes up and then goes closer to its asymptote. Remember that the asymptote here is x is equal to 0. Remember that the asymptote for a logarithmic function is solved by looking at the argument and then setting it greater than 0. So therefore, the function should only appear x greater than 0. That's why the asymptote is here. X is equal to 0. Right? Hope you recall that, because that will come in handy. So graphing a logarithmic function would also come in handy when finding its limits. And then what about the limit of x, log of negative x? So same thing, negative x is greater than 0, and then divide both sides by x by negative 1. That becomes x is less than 0. That is why the value of the function are all on the left side of the function, right? And then it goes up to the left, in contrast to log of x, which goes up to the right, right? Now, how about the negative log of x? So it's actually a mirror of log of x, whereby the mirror is actually the x-axis. So it's basically these two are actually related to one another. All right. So instead of, as you can see here, the behavior of the function is that as we increase the value of x to positive greater numbers, of course, the value of the function, which is logarithmic, also increases in value. But here, as we increase the value of the x, which is going to positive infinity, the values of the function goes down. Why is that? Because it is going to negative infinity. Remember that we're taking the negative values, or we're taking the values of the function here and making them negatives. That's why it goes down to negative infinity. And similarly to this fourth function that we have here, the negative log of negative x, it is just a reflection of this function here about the x-axis. All the positive values that we see here are reflected as negative values, right? So I hope you recall some of these things already. So we will go ahead and talk about the limits of logarithmic functions. So one more thing, by the way, before we go to the limits of logarithmic functions, let's talk about the shifting in the graph of the function. This is the log of of x, and what happens if we have a log of x plus 1? It is actually a horizontal shift, with a shift following, the negative value of the shift here. So that if, for example, that is log of x plus a, so therefore if we have a positive a, it is a shift to the left. If we have a negative a, it's a shift to the right. Why is that so? Because remember, in finding the asymptote, we say x plus 1 greater than 0. We say x is greater than negative 1. So therefore, negative 1 is here. So that's the asymptote there, whereby the function, or which is the function, is going closer and closer to. and a value which is outside. So these two are not the same, okay? Because the plus one here is a plus to the argument. The plus one here is plus to the logarithm itself. That is actually a vertical shift. So the vertical shift here would follow actually the sign of um, the added value. So if it's an addition or a positive, meaning it's um, a shift above or a shift up, and if it's a negative here, it's a shift down. So I hope you still recall that. So let's have a few examples here. I have four in finding the limits of logarithmic functions. So let's first go ahead and graph or sketch the graph of the function. Now we have here log of x where the asymptote is located at x is equal to 0. So it should look like this. So where does the function go to as x approaches to positive infinity? It is going to positive infinity as well because it goes up. All right. So the growth of the value of the function, a logarithmic function, may be very, very small compared to that of an exponential function, but we know that it would still go up indefinitely. Now, how about for the second example here? We have the same function, but it goes to 0, goes closer to 0 from the left. So, meaning this is 0, sorry, from the right, I mean. This is 0, and what happens as we move the values going closer and closer to that? The value of the function um, is actually going closer and closer to its asymptote without bound. It's going down actually. So therefore, we would say it's a negative infinity. How about this next example? As you can see, we have the same functions here, but that's a negative. Um, that's a negative here. So therefore, how would it look like? So it would look like this. All right, something like that. Um, so how does the function behave as it goes closer and closer to negative infinity? The function goes to positive infinity. It goes up still. This one here, as we go closer and closer to 0 from the left, meaning to that direction, the function is going to negative infinity. Okay. Now let's have more complex functions, examples later on. Let's go to the generalizations first. So therefore, if we have a log of x to the base b, so long as b is a positive, then therefore x, as x approaches to infinity, the whole function goes to positive infinity as well. If ever we have a log of x to the base b, as long as the base is positive, as x approaches to 0 from the right, then it is negative infinity, right? So these are just really generalizations, but most of them, when you would want to find the limit of the logarithmic functions, it would be very, very good to start with a graph because you'd have like a visual of how the function behaves. Now, it also applies for the natural logarithms. Remember that natural logarithms are functions or logarithms whose bases are Euler's constant E, right? So remember ln x is just equal to log of x to the base E. So therefore um, the generalizations that we have for 1 and 2 would be applicable for 3 and 4 as well. All right, so let's have more complex examples here. Let's start with log of x minus 4 as x approaches to positive infinity. So again, the first thing that we need to do is to find the asymptote in order for you to sketch the graph of the function. So in order for you to find the asymptote of a logarithmic function, we take the argument and we set it greater at 0 and solve for it. So for x. So x is greater than 4. So therefore, we know that the asymptote is at 4. X is equal to 4. So it'll be around here. So because that's an asymptote, we write it as a broken line. And then it is on the right of 4 because it says greater than 4. So goes to that direction. We know it goes up because it's a positive x that we have here and not a negative here as well. Okay, so let's continue on that. So how does the function behave as x approaches to positive infinity? Well, the function goes up indefinitely, so that is a positive infinity. How about the next example that we have here? The limit of negative log 2 to the 2x as x approaches to 0 from the left, from the right. So the log here, there's no shift, vertical, horizontal, but it's a negative, so therefore it would look like that, right? It's a reflection on the x-axis, about the x-axis. So it goes up there and it goes down here. Now, how does the function behave as x approaches to 0 from the left, 0 from the right? Sorry for that. It is actually going above without bound, so that is negative infinity. Okay, how about the next example that we have here? So we have your log of 4 minus 2x as x approaches 1, as x approaches infinity. So how do you sketch the graph? So first is that, again, we go ahead and solve for the asymptote. So we have 4 minus 2x as greater than 0, and we say negative 2x greater than negative 4. We divide both sides by negative 2. That becomes x less than 2. Remember that if we divide and multiply um, uh, an inequality, it actually changes direction, right? So meaning we have x is less than 2. So by that, we have a hint that first, the asymptote is located at positive 2. So it's here, but the graph is located on its left because it's less than. Okay, now because there's no negative here, therefore it should look something like this, right? So meaning if this is positive here, it is going up always. If this is negative here, it is going down always, right? So how does that look like? How do we find the limit of the function as x approaches to positive infinity? Technically, we would say that as it goes to positive infinity, how does it look like? How does the function look to you? So the function is actually still going down. Even if we go past 2, which is again, um, which is something that should not happen, because we can't really take values that are lesser than 2, because that becomes 4 minus 2 times 2, which is 0. Logarithms, or like the argument of logarithms, should always be positive, meaning greater than 0. So therefore that should be undefined, but just basing off from the behavior of the function as we go to the left or we go to the right, the function is going to negative infinity, okay, because it goes down. Now about the limit of this next function here. So quite long, but let's try to look at how the shifts would affect the function itself. So first we start with a argument, negative 3x minus 4 greater than 0. That's negative 3x greater than 4. X is less than 4 thirds. Right? It's negative 4 thirds. So therefore we have negative 4 thirds. So that's a little bit over 1. And we know that the function would be around to its left. Okay. And we have a shift of a positive 4, meaning it's going up. Because it's a negative, it should go down. So something like that. All right. So here it says 0 from the left. So, but the 0 is here, right? But the direction is going to that direction, the value of x. So how does the function behave? The function is going up indefinitely. So therefore it's a positive infinity. So I hope you get to review on how to graph or sketch the graph of a logarithmic function, so that this topic for you would be much easier. That's it for now. Thank you so much.